Okay, so hello everyone. My name is Kunal and I'm your physics tutor. And we're actually doing ray optics. And today is our actually eighth lecture on this topic. And let me quickly recap the things कि हमने previous classes में क्या क्या चीजें cover करी थी. So in previous classes हमने magnification पे discuss किया था, जिसमें हमने आपको बताया था the magnification are of two kind. One is actually transverse magnification, and other is of longitudinal magnification. Right. So ये सारी चीजें हमने डिस्कस करी थी इन प्रीवियस क्लास में और वी आर एक्चुअली गेट अ रिलेशन बिटवीन बोथ ऑफ देम, है ना. हमने इन दोनों के बीच की एक रिलेशन भी स्टैब्लिश करी थी. राइट. सो and what was the relation was, so first I'm going to write like what is transverse magnification formula. So it's simple, like height of image by height of object is equal to minus negative of distance of object image from pole and divided by distance of object from pole. And what is the formula for the longitudinal magnification? So ml is actually is equal to length of image by length of object, and it is actually equal to minus of negative of square of distance of image from pole divided by square of distance of image from object from pole, right? So these are the formula that we derived in our previous classes, and we get a relation, very good relation between longitudinal magnification and transverse magnification, and the relation is actually ml is equal to minus of m square, right? जो हमने और यहाँ पे ये बताया था कि नेगेटिव साइन क्या रिप्रेजेंट कर रही होती है. So the negative sign is actually representing the inverse, the inversion of the image, right? So these are the things that we are actually discussed in our previous class. Okay. So now in today's class, we are gonna actually discuss about our new topic, which is actually velocity of object and images. Okay. So this is our actually new topic that we are going to discuss in today's class. जैसे कि हमने velocity पे discuss करी थी previously for plane mirror, right? हमने plane mirror पे discuss करा था. तो उसमें कुछ कुछ relation आया था for parallel, for perpendicular. So same way we are going to discuss for the spherical mirror. So I'm going to write it here. We are going to discuss about the velocity of the object and image for the spherical mirror, right? So as we all know, like we are starting from the case one actually, like velocity of object along principal axis. So these are the some cases that we are going to discuss today, and the same like along the principal axis and perpendicular to the principal axis. So there are only two, and then whenever some with some angle, so we take the component and try to find it out. So the first case we have to deal with like this: either the velocity is in direction of parallel to the principal axis and perpendicular to the principal axis, right? So I'm taking the first case when the velocity of object is actually along the principal axis or parallel to the principal axis. You can say like this. Okay. So let us suppose this is actually our concave mirror, and this is actually our let us called as object, which is actually moving in the rightward direction, and let us suppose this is actually our image. I'm just assuming, right? This is not gonna be a fact. I'm just assuming that the object is moving in the rightward direction and somehow image is moving in the leftward direction. I'm not gonna like, I'm just assuming that. Okay. ये मैं claim नहीं कर रहा हूँ कि ये यही हो रहा होगा. It may be something, the scenario may be different, right? I'm just assuming here that the object is actually moving in the rightward direction and the image is actually moving in the leftward direction. So I'm just assuming. Okay. So you have to keep this in mind, and there is actually our code. So now onward, uh, like as you all know, the U is actually representing the distance of object from the pole, and V is actually representing the distance of image from the pole. So I'm gonna writing here as we have to write the velocity. So I'm writing here du by dt. So what's the du by dt representing? So it's actually representing the velocity of object as you actually represent the distance of object from the pole. So that's why when we differentiate it with respect to time, we get the velocity of the object, but we are actually taking with respect to the mirror. as we do in the plane mirror thing. So velocity of the object with respect to the mirror. So it is actually equal to velocity of object with respect to mirror, right? And this is actually a vector quantity. Velocity is a vector quantity. So we just need the direction also. Okay. Now the second thing is actually dv by dt. And you all guys familiar with what is v? So v is nothing but distance of images from the pole. So when we differentiate the distance of image from the pole, so we get the velocity of image. So this is actually our velocity of image with respect to mirror. And this is actually is equal to velocity of image with respect to mirror. Okay, so this is the way to represent, right? So now we all have to actually move from or the move through the only formula we have is actually mirror formula as we derive it in the previous to previous class, right? The day before the previous class we derive. So let's proceed from that. So from mirror formula, and what is actually mirror formula is 1 by u plus 1 by v is equal to 1 by f, right? So what I'm going to do here is I'm just try to differentiate. So when we differentiate with respect to, you can do with the respect of time because we actually need like du by dt and dv by dt kind of thing. So what I'm going to do here is differentiate with respect to time. Okay. Okay. So as you differentiate with respect to time, so what you get? We all know the differentiation of 1 by u will be like minus 1 by u square du by dt. Similarly here like minus 1 by v square dv by dt. And there will be 0 because it is representing the length and the focal length is actually constant for each of the mirror, right? So this will be 0. So what we will get from here, we will get, if you look at here like dv by dt is actually is equal to, to somehow get u square minus u square by v squared. Let me write it here in a clear way because it's u and v is quite look like same, right? So, okay. So as we, so the dv by dt actually look like minus of v square by u square, and here is we get du by dt. Okay, and in from previous class we all know that this is actually our the v square by u square term is nothing but it is actually longitudinal magnification, or you can say this is actually nothing but minus of m square du by dt, or you can say similarly, or let me write it here, or dv by dt is actually equal to ml du by dt, right? Where ml is actually your longitudinal magnifications, right? So, this is the result we get, and we get a very good relation between the velocity of images with respect to mirror and velocity of object with respect to mirror. So we can write this also as, let me write it here. We can also write it as velocity of, this is actually image. So velocity of image with respect to mirror is actually is equal to longitudinal magnification into velocity of object with respect to mirror, or you can say, so these all are same, right? Or you can say velocity of image with respect to mirror is actually equal to minus of, this is actually transverse magnification, right? Minus of m square velocity of object with respect. So these all are same. So in this case, we are assuming that we are actually assuming that we have the velocity of object is actually along the principal axis. So this case that we are discussing right now, in this case, we are actually assuming that the velocity of the object is actually along the principal axis. And then we derive these kind of things. Okay. So, okay, I hope it will be clear to all of you. Now, again, I'm going to tell you after few time when I derive after deriving the second case, this is actually then the velocity of the object is actually perpendicular to the principal axis. So let's start. Okay, so we have a case too also. So in this case, we have a case like velocity of object, perpendicular to principal axis. Right. So this time we are assuming that uh, let me write here. Like suppose that this is actually our concave mirror and this is actually our principal axis. Assume that okay. Let me make a straight line. Can I insert? Yeah, I can insert from here. Okay, that's fine. I think I have to do something. Okay, that's fine. That's fine. Okay. So this is actually our principal axis, and I'm assuming that if this is actually our object, so it is actually, I'm just assuming that, okay, this is not the fact that I'm just saying the object is only going in the upward direction. So I'm just telling this is actually the object is actually moving or the object has a velocity in the direction of perpendicular to the principal axis. So this is actually object and this has a velocity of object. And I'm assuming that, I'm just assuming this is not the true for the each and every case. And I'm assuming that the velocity of image in the downward direction. Okay. So yeah. This is actually our AD. So you have to derive some formula for this also. So what else we can do here? Let's start. Okay. We have here, as we derived in the previous classes, like for the transverse magnification. So we have a formula, right? Let me write it here. From transverse magnification, right? We have a formula which is actually states that the transverse magnification is actually equal to height of image by height of object, right? So we can write it here like HI, because if we have to find the, like it is in, if I'm going to assume it here like X direction or Y direction, if I am considering the direction of principal axis is X axis, so our direction of velocity is in Y direction. That means dy by dt something represent the velocity in Y direction, right? Look at here. In the previous one, when the velocity of the object is in direction of principal axis, so what we do the du by dt and the dv by dt, because we have the du or the u representing the distance of object from pole. So this is actually lying in this direction, in the direction of principal axis, and the v is also representing the distance of image from the distance of image from the pole, right? So it is also representing in the x direction. So whenever we have to find the velocity along the principal axis, if I'm assuming that the principal axis is actually lying in the direction of x axis, and the so in the first case when the velocity is actually lying along the principal axis, so we have to do like dx by dt something to find the vx. This is actually the normal kinematics that you learn in the chapter motion, right? This is actually the normal kinematics that I'm doing here. So for the similarly, now our object is actually moving in the direction perpendicular to the principal axis. So what we have to do, we have to do like dy by dt kind of thing. And we have the only things in the as in the function of y direction is actually its height. So so actually that's why we have to move from the transverse magnification, right? So I hope it will be clear to all of you. Uh, okay, so let's start. So here we have a if I go through this equation, so we have like as height of image is actually is equal to m times of height of object, right? And differentiate with respect to time again, right? Because we have to find like dy by dt kind of thing as I mentioned here. So we have the only things that in the y direction is the height of the object or the images. So what I'm going to do here, I'm going to differentiating with respect to time. So as you differentiate with respect to time, so what you get like dhi by dt. And I'm assuming that the magnification is constant, right? Because somewhere magnification, because I have to, this is actually the form like xy. So we have to apply like d of xy when we do, we have to apply the product rule. As you already learned this thing in differentiation chapter, whenever we differentiate in a of variables which is actually lying in the product form, so we have to apply the product rule, right? So whenever I differentiate here with respect to time, So dhi by dt is actually equal to, I'm assuming that the m is actually constant, right? So let me write it here, and then I'm gonna write it because it's something confusing to it. So dho by dt, I'm just applying the product rule here. Let me write it here. Product rule. So dho by dt plus ho dm by dt. Okay. So now, actually, in actually manner, we get here like velocity of the, this is actually our images. So velocity of image with respect to mirror is actually is equal to m times of, which is actually transverse magnification, ho by, which is actually velocity of object with respect to mirror plus height of object, and this is actually representing something dm by dt. I don't know about the dm by dt kind of thing. So actually the formula for the velocity of object or the velocity of image when the velocity of object is actually in the perpendicular direction to the principal axis is that. But if our m is constant, okay, if m is constant, okay, if m is constant, so what we get? So we get like dm by dt is actually is equal to 0. Let us call as equation number 2. So from equation 2, what we get? We get velocity of image with respect to mirror, and this term gets 0. So we what we get? We only get the m times of velocity of object with respect to. I hope this will be clear to all of you, right? And we all know that the magnification is nothing but negative of minus v by u. So that is the thing that we actually derive or learn for the today's class, right? Now, what we have to learn, the next thing what we have to learn is, so this is actually, this is the thing I think clear to all of you. So let me recap again for the short interval of time. So, okay. So we are actually, we have to find, as we deal in the last lecture about the magnification. So we are actually trying to use those concepts to find the velocity of images, right? Like, so whenever we talk about the velocity of image, so what the things that you, what the things that comes in your mind? So the things come is in mind is, what is the velocity of object? If the object moves, then the images moves. Now, when the things come for the movement, so in that case, we are assuming for the two standard cases, then we can, अगर यहाँ पे देखो मैं बताता हूँ, अगर यहाँ पे आपने लाइक अगर कह दिया कि किसी एंगल से प्रिंसिपल एक्सिस से 30 डिग्री के एंगल पे मूव कर रही हो ऑब्जेक्ट, सो what we do here is I just take the component, one in the perpendicular direction to the principal axis and one in the parallel direction to the principal axis or the direction in the principal axis. So we get easily, right? So what I'm doing here is I'm just trying to derive the formula for the velocity of image to find the velocity of image for the two standard cases. The first case is actually when the velocity of object is actually in the direction of, is actually along the principal axis, or you can say is actually in the direction of principal axis. So what I'm doing here, we are actually using the normal kinematics as I earlier told you. Let us assume that the principal axis is actually lying in the direction of x-axis. Okay, and the perpendicular to the principal axis is actually y-axis. So what I'm doing here is I'm just trying to find the du by dt and dv by dt. And you all know like what is u and what is v. So u is nothing but the distance of object from the mirror, or you can say pole. And the v is actually distance of images from the mirror, or you can say pole. So now we have a simple formula, mirror formula, as we derive in our, the, I think fourth or the fifth lecture. So it is actually 1 by u plus 1 by v is equal to 1 by x. And similarly, we have to find like du by dt. So what I'm doing here, I'm just trying to differentiate the mirror equation with respect to the time. So after differentiating, we get a relation here, which is actually dv by dt is equal to minus m square du by dt. And m square, we all know, it is actually the transverse magnification formula. So here we get velocity of image with respect to mirror is actually is equal to minus of m square into velocity of object with respect to mirror. Okay, so I hope this will be clear to all of you. Now, I assuming for the second standard case, which is actually when the velocity of object is actually perpendicular. Okay, is actually perpendicular to the principal axis. So in that case, what I'm doing. So in that case, what I'm doing in that case, I'm trying to correlate with the transverse magnification because this is the only thing that we have in the y direction. Whatever else we have is actually along the principal axis because whenever we measure the distance or the object distance and the image distance, it's actually along the principal axis, not the perpendicular to the principal axis. So actually, I hope you'll all get what I'm trying to say because whenever we measure the object on the image distance, we measure along the principal axis, not the perpendicular to the principal axis. So the only thing we have is in perpendicular to the principal axis is the height of object and the height of images. So what I'm trying to use, I'm trying to differentiate the magnification same. So when I do so, we get a relation actually velocity of image with respect to mirror is actually is equal to velocity m times of velocity of object with respect to mirror plus height of object into dm by dt, which is actually magnifications is actually differentiating with respect to time. What if our m is constant? So the when m is constant, we have like dm by dt is actually equal to 0. So from the equation number, from the above equation, above mentioned equation, we get like velocity of image with respect to mirror is actually equal to m times of or the transverse magnification times of velocity of object with respect to the mirror. Okay, I hope this will be clear to all of you. Now we are going to talk about the position of object and image for the concave mirror, and then we are going to discuss for the convex mirror. Okay, so let's start. And okay, so we are starting position of object and images in concave mirror. Okay, it is actually very important. Actually इसका मतलब यहाँ पे ये है कि मैं आपको शायद पहले से पता भी होगा बट आई एम ट्राइंग टू इलाबोरेट इन सम डिफरेंट वे. सो द क्वेश्चन इज कि मैं ऑब्जेक्ट को कहाँ पे रखूं. सो फर्स्ट ट्राई टू first I'm gonna make a concave mirror here so that it will be okay, and let me make a hope again. So let me insert a straight line here. Okay, so this is actually our straight line, which is actually the principal axis. Fine. So this is actually our this is actually our focus. This is actually our center of curvature, and this is actually our pole. So these are the three basic things that we have to represent in a mirror. And I'm considering that this is actually our principal axis. So this is actually plus infinity, and there is actually our minus infinity. Okay, so the principal axis is actually lying between the minus infinity and the plus infinity. Now, let's move to the what? The mirror formula, right? So we have a mirror formula is actually, let's start with mirror formula. देखो इस टॉपिक में हमें सीखना हो क्या मिलेगा कि कहाँ पे ऑब्जेक्ट रखें तो इमेज कहाँ बन रही होंगी. ओके, सो दीज आर द थिंग दैट वी आर गोना लर्न इन this topic. So let's start with the mirror formula. So from mirror formula, what we actually it is actually like 1 by u plus 1 by v is equal to 1 by f, right? This is the mirror formula. 1 by u plus 1 by v is equal to 1 by. Now, what if, now here our actually focus is actually in the negative direction. When we put the sign convention here, right? When we put the sign convention here, and I'm not assuming that the things were, the object were in right direction and the image were in right direction. So what else we can do here? If I'm going to do here is something like, let me write it here. So 1 by v is actually is equal to, we can write minus 1 by u minus 1 by f. I'm just taking this from that side. I'm just considering it as negative. We can do this thing. So we have a formula like v is equal to minus of uf by u plus f, right? We put sign in f and we further put sign of u. What we do here, we put the sign. I'm already told you in our, when I taught you the sign convention, because the sign convention is the only things जिसकी वजह से आपकी आंसर गलत आ सकती है। बाकी कॉन्सेप्ट ऑप्टिक्स के सारे इजी होते हैं, ठीक है। यू हैव टू जस्ट कीप सम फॉर्मूलाज एंड स्मॉल स्मॉल की पॉइंट्स इन योर माइंड. You can you are actually able to solve any level of problem of the optics. Just you have to keep 2 or 3 things in mind. You have to apply, you have to know how to apply the proper sign convention, जिसकी मैंने easy trick भी बता रखी है. You can go through that lecture. Second things, आपको बस छोटे छोटे की पॉइंट्स लाइक रे डायग्राम में कितने रे चाहिए होती है, ये सारी जो मैंने बता रखी है, छोटे छोटे की पॉइंट्स आपको दिमाग में रखने हैं. एंड द थर्ड थिंग्स यू हैव टू कीप इन माइंड इज फॉर्मूला. दैट्स इट. These are the three, actually you can say, what you can say, it's like a useful tool via which you can solve any level of problem of the optics. So let me write it here. What I did here, I actually put the sign in F, that means focal length. I put as negative, as you look at here, and then we further put sign of U. Okay, so I hope it will be clear to all of you what I'm trying to say. Now, so this is the thing that I'm gonna start with the normal mirror. Now let's talk about for the real object and for the real image and for the virtual object. So now start the things. So the first thing is for a real object. Okay, so whenever I'm talking about the real object, what it's mean? So that means is when the incident ray of light, is actually when the incident ray of light is actually have a visible intersection point or the real intersection, right? So this is actually for the, or you can say in the case of concave mirror, that the object is actually lying in front of the, I mean, this is the range for the real object. You can say like object in lying in front of the concave mirror. That means you have a object, let me write it here, for real object in between, you can say minus infinity to pole. इन दोनों के बीच में हमारी ऑब्जेक्ट रखी हुई होंगी, राइट. सो हियर वी हैव लाइक v is equal to, since we all know, minus of uf by u plus f, right. So the object is real, that means real object, that means u is actually negative, है ना, u is actually negative. So what we get, this is actually equation 1. So what we get v is equal to, here we put the negative, so numerator become positive, so minus u plus f. So you don't have to, you have to just keep in the mind the formula, है ना. आपने बस करना है कि आपने बस फॉर्मूला को दिमाग में रखनी है एंड साइन कन्वेंशन को सही से यूज करना है. ओके, सो दिस इज द थिंग फॉर द रियल ऑब्जेक्ट. नाउ वी हैव सर्टेन केस like what if u is greater than f, u is less than f, है ना. So these are the cases we are gonna discuss here. देखो यहाँ पे इसका सब केस चल रहा है, दैट मीन्स 1 का फॉर रियल ऑब्जेक्ट के केस में हमारे पास v जो आया, दैट मीन्स द डिस्टेंस ऑफ इमेजेस फ्रॉम द पोल इज लाइक दिस. And now we have to take the further cases when u is actually greater than f, u is less than f. So these are the cases that we're going to take it here. So I'm going to take it as a case A, or you can say case 1A. Okay, so when u is actually greater than f, that means obviously we have like object in between minus infinity and focus. Right, because we have u is actually greater than f, that means object is lying in this region. We are considering this case when the object is lying in this region. U is greater than f. So from v, as we have like uf by f minus u. So when u is greater than f, so this term is actually negative. This term is actually less than 0. That means v is negative. That means real image. We have actually real image. And you have to keep one more thing in mind. The image is actually inverted. What I'm doing here, I hope you all get what I'm trying to do here is, right. I'm just considering that I am just considering here is for u is actually greater than f. When our object distance is actually greater than the focal length in case of concave mirror, and when the object is real, so what we get like uh, उस केस में रियल इमेज बन रही होंगी और इन्वर्टेड इमेज बन रहा होगा. Okay, so this is the case that you have to keep this thing in mind. Actually these are just easy things, right? Now let's take the case 1b, in which or you let me write it here a noted point so that you can keep some points in mind. So if object and image are on the same side, then it is actually inverted, and otherwise and when it is in a different side, it will be erect. So you have to keep this thing in mind. Like मैंने यहाँ पे inverted लिखा ना, तो आप पूछ सकते हो कि आपने inverted क्यों लिखा, erect क्यों नहीं लिखा. तो वही मैं concept आपको दे रहा हूँ कि when object and images are on same side, then it is inverted. Okay. Otherwise, or you can say for different side, erect. And in this case, we have object is actually real object. So actually u is actually negative. That means it's actually lying in front of mirror. And for the case when the object distance is actually greater than focal length, so in that case also we get the v is also negative. That means image is also lying in front of mirror. So that means the both of the image and the both of the object and the image are actually lying on the same side of the mirror, in front of mirror, right? So the image will be inverted. And whenever you get any kinds of cases in which the object and the mirror are actually lying in the different side, that means one lying in the frontal side in the front of the mirror and other lying in the backward of the mirror, so basically back side of the mirror. So in that case, the images will be erect. So you have to keep this in. This is actually important noted point. Okay. Now, okay, where I am? Oh, I have to discuss the case 1b. So case 1b. So in that case, we are going to discuss like when u is actually less than f. So when u is actually less than f, and we have a formula which is actually v is equal to uf by f minus u. So this will be get as a positive. That means this is actually greater than 0. V is positive. So when v is actually positive, so what we'll get? We'll get a virtual image, because it will be in the backside of the image, right? And when now we have images is on the front of the mirror, and sorry, object is in the front side of the mirror, or you can say object is lies in the front side of the mirror and the images is lies in the back side of the mirror. That means object and images are not lying in the same side of the mirror. Object and the images are actually lying in the different side of mirror. Object lying in the frontal side, image lying in the backward side. So in that case, the image will be virtual, erect. Virtual तो वैसे ही हो रखा है क्योंकि वो backward side में बन रही है ना, because of we get the v as a positive, है ना. So it's actually lying in the positive. V is actually our positive, so it's actually virtual because it's lying in the backward direction of the or the backward direction of the concave mirror. And since we have object is in frontal side and image will be in backward side, so we have actually object and image will be in two different side of the mirror. So we get the image will be as erect. Okay. So I hope it will be clear to all of you. Now let's take the second case. This is the case we are assuming for the real object. Right. This is the case we are assuming for the real object. What if we are considering the case for the virtual object, right? What else if we are considering for the virtual object? So let's start with the virtual object here. So the second way, term, like, okay, in the concave mirror part. So for virtual object. So what is actually virtual object? So when the incident ray of light is appear to meet, right? So in this case, whenever the reason for the virtual object is that when the object is actually lying in the backward side of the mirror. So this is actually the virtual object region. And the virtual object region is actually when the object is lying between the pole and the plus of infinity. I'm just dividing it into some section. I'm just considering the principal axis as an x-axis, and I'm just dividing it into some sections. Right? I'm just dividing it into some sections. So I hope it will be clear to all of you. Hai na? Okay. So now what else you can do here? Okay. So we have a reason. So let me write here the reason that object is lying in between pole and plus of infinity as you look at it. Because our object is actually lying in the backside of the plane, right? Backside of the plane. So here, what else we can we do? That means we have a u is positive because we have like object distance. Because look at here, whenever you take like a ray of incident light, so it's actually passing from the right to left. So it will be actually lying in that direction. So we have like object is there, and from sign convention, as I told you the trick, कि आपको बस incident ray of light को follow करनी है. If that object is lying in the direction of incident ray of light, it will be taken as positive. Else we have to take as negative. So here the u is actually positive. Okay, and we have a formula here which is actually v is equal to minus of uf by u plus f. And why it is? Because the f is negative, right? Focal length is always negative. In that case, it's actually lying in there, right? So focal length is obviously negative. So we have a formula like this. And since the u is actually we have positive, so this is always negative. What I'm trying to say here, v is always negative. Like previous में हमारे पास दो cases आई थी. The first case is like when u is actually we have positive. जब हमारे पास u positive था, तो we have something. नहीं, जब u f से बड़ा था, then we have some different case. And when u is less than f, that means object distance is less than focal length. So our पास cases different थी. But in that case, what we are assuming here, okay, so in that case, what we are assuming that कि यहाँ पे कुछ भी ले लो आप, यहाँ पे हमेशा जो इमेज डिस्टेंस होगी वो हमेशा नेगेटिव होगी. दैट मीन्स इमेज इज एक्चुअली रियल, राइट? एंड यू कैन से इमेज इज ऑलवेज रियल. देयर इज नो सब केसेस, ऑलवेज रियल. Image is actually always real and erect. Why? Because object is actually lying in the backward side of the mirror and image is actually real, so it's lying in the frontal side of the mirror. That means object is in there and image in this in the frontal side of the mirror. So that's why the image is real and erect. Okay. So I hope it will be clear to all of you what I'm trying to say. है ना? आपको समझ में आया होगा चीजें? In tomorrow's class, we are going to discuss about some special cases of real object near the focus. क्योंकि देखो हमने क्या क्या डिस्कस करा. हमने डिस्कस करी for the real object, for the virtual object. आपको मैंने बताया होगा when I am discuss about the ray diagram कि whenever a ray of light is actually passing through the focus, so after reflection, the ray of light is actually moving parallel to the principal axis. That means it goes to the infinity. या फिर आपको इतना पता होगा जब फोकस पे इमेज होता है, जब फोकस पे ऑब्जेक्ट होता है तो इमेज इनफाइनाइट पे बनती है. या फिर जब आपके पास इनफाइनाइट पे इमेज हो तो फोकस पे इनफाइनाइट पे ऑब्जेक्ट हो तो फोकस पे इमेज बनता है. फोकस पे ऑब्जेक्ट हो तो इनफाइनाइट पे इमेज बनता है. दीज आर द थिंग दैट यू हर्ड इन योर क्लास 10th और 12th, राइट? सो सॉरी 12th तो आप हो ही अभी, 10th में आपने सुना होगा या 8th में सुना होगा, है ना? बट वी आर एक्चुअली ट्राई टू फील इट नियर द फोकस, जस्ट नियर द फोकस. ये सारे केसेस हम लोग डिस्कस कर रहे होंगे कि कहाँ कहाँ पे इमेज बन रहा होगा. एंड यू लिटरली गेट शॉक व्हेन यू लर्न दिस कॉन्सेप्ट, बिकॉज इसमें काफी सारी नई चीजें आती हैं. लाइक हमें पता होता है कि जब फोकस पे ऑब्जेक्ट रहेगा तो इमेज इनफाइनाइट पे बनेगा. बट अब हमें यहाँ पे दिख रही है कि वी हैव टू इनफाइनाइट, एक माइनस इनफाइनाइट है, एक प्लस इनफाइनाइट है. नाउ क्वेश्चन इज कि किस मतलब पॉजिटिव साइड में बनेगा पॉजिटिव इनफाइनाइट साइड में हमारा इमेज बन रहे होंगे या निगेटिव इनफाइनाइट साइड में इमेज बन रहा होगा, right? So these are the concepts that you are going to learn in tomorrow's class. I hope it will be very interesting lecture, and you learn a lot more things from today. And tomorrow's lecture we are going to discuss these things. है ना, ये टॉपिक काफी इंपॉर्टेंट है कि हमारा जब ऑब्जेक्ट फोकस होता है तो इमेज इनफाइनाइट बनता है। ये चीजें आपने 8th में भी सुनी होगी, 10th में भी सुना होगा, बट नाउ वी आर गोना डिस्कस पॉजिटिव इन्फिनिटी साइड बन रही होगी, नेगेटिव इन्फिनिटी साइड बन रही होगी, and we conclude this thing with a valid evidence. Okay, so that's all for today's. Thank you. I hope you learned a lots of things from the today's lecture.